Hello, this is Jimmy Lee. We are going to learn about CMOS VLSI design. This is course information. The textbook is CMOS VLSI design, circuits and system perspective. So we will need you to take the prerequisites such as electric circuit design, digital design, electronic circuits. So of course we'll have a midterm and final. I'm not sure about the homework or project. Probably we'll have a midterm and final. We will go through and decide later. We'll skip. Okay, so we are dealing with lots of transistors to design integrated circuits. Integrated circuits is a part of a system made of chips, board, and software, etc. So most of the students after graduation, they go to Samsung SK, LG Dongbu, something like that. But if you look for going abroad, there's Intel, AMD, and Qualcomm, TI. All those worldwide companies is also you can find the job there. This is the typical system breakdown. iPhone 5, if you, for example, we have a Wi-Fi chipset on the right, and also on the left we have a power amplifier and antennas and switch. All those are analog building blocks. On the bottom there's a big application processor A6. This is made out of all digital building blocks. And also we have a cellular modem on the left. That is also digital block. This digital block is tightly coupled with the cellular RF TRX building block. So for VLSI you have to deal with all these kind of subsystem in especially for digital system. If you want to look inside the application processor, you can guess what's inside in the next slide. This is typical ARM core breakdown. There's a memory controller and graphic controller on the top, and DSP core for heavy or mathematical operations. On the right we have I/O circuitry, and also on the bottom there's the interface building block. And also memory controller unit. All these kind of complicated function we have to build to make a product, right? So this is quite challenging to understand all these operations, but in the end the underlying principle is to designing a digital block, right, properly. So we will learn about how we design a digital circuits throughout this course. So in this course we will cover lots of transistors, but all these transistors works as a switch to deliver logic 1 or 0. So the key issues is creating logical structures from transistors. Because there are so many transistors, you have to be very consistent and logical to build a complicated system. Once you build your system, you have to analyze and optimize your system. And also you also have to consider testing before you actually tape out. You also need to take care of power consumption and how you're gonna deliver clocks and how you are gonna give in the data or you take out the data out of your chip. Cheating will not be tolerated, but discussing with your colleagues is okay. So let me briefly start with the typical IC design. IC design can be either analog or digital or both. Typically, we are dealing with full custom design or ASIC application specific integrated circuits. We design a digital block from CAD tool. The tool will synthesize whatever you write for the function. A semi-custom method is kind of a mixture of custom and synthesized module. So you have to learn and build your skill to design both full custom and ASIC method, right? This is it. Semiconductor sales revenue worldwide. As you can see, the sales going up and up, right? Actually, industry is growing. This is the top 10 semiconductor company worldwide. For example, 2018, Samsung is ranked first, and Intel ranked second, and third one is SK Hynix. The first and third are Korean companies. You can be proud of these facts. But all these companies are mainly focusing on memory. But for the non-memory business, Intel is number one, and so TSMC is foundry company who take the designs from Fabless company. They build the circuits and for the Fabless companies. Broadcom and Qualcomm are also major player for non-memory business. They build all kinds of data processing building blocks or the communication chips. And Toshiba is Japanese company, listed 8th in 2018. NVIDIA, as you know, they are building graphics chips. This is the recent online news. The title says the only one out of a top 50 company is listed as a Korean Fabless company, and also there are many lack of design engineer. So every year, so this circuit design field is a very demanding area. If you look at on the right, an application processor is kind of the CPU inside the cell phone, it is non-memory chips, and among all the worldwide market share, Samsung Electronics taking only 12% of the market share at 2018. So we can make it trying hard to take more market share, and they need more and more engineers nowadays. If you wanna know about the Korean foundries IC companies, there's a whole bunch of the list here. The number one player in Korea is Silicon Works. This company make chips for LG display. They're mainly display driver IC. And Telechips is kind of automotive communication IC. AD Technology, Above, Semiconductor, all these small companies that are working tightly with the big company like Samsung and LG and SK Hynix, something like that. So you can find many jobs over here other than the big player like Samsung or LG. So if you go to a small company like these, you can learn a lot and gain your experience better, right? Yeah, if you go to a big company like Samsung, you always design small block and you don't have enough skill. You don't have an opportunity to learn many circuitry. So it is also a good choice to go to a small company and take some bigger role there and lead the company, right?